Welcome to Lesson 12. This is our last lesson in the series. And today we're going to be talking about New York exam translating words to inequalities. So I wanted to bring in some past exam questions so you can see the possibilities of work you might be asked to answer and where we want to take our knowledge in translating words into inequalities. So we're going to work through the first two problems, and then I'm going to ask you to work the second two problems independently. So let's get started. Harper has $15 to spend at the grocery store. She is going to buy bags of fruit that cost $4.75 each and one box of crackers that cost $3.50. Write and solve an inequality that models this situation and can be used to determine the maximum number of bags of fruit, which they're giving us the variable b, Harper can buy. So let's go back and look at the information that it gave us initially. It mentioned that Harper has $15 to spend. So if I think about it, Harper cannot go over $15, but could spend up to $15. So if I just sketch this out, whatever Harper is spending, so if this side is this is what she spent, it cannot be any more than $15. So it could be less than $15. So that's the less than symbol. It could be equal to $15. Let's look at the rest of the information. She is going to buy bags, so I guess that's plural, of fruit that cost $4.75 each. And they gave us the variable b to represent the number of bags of fruit. And she bought one box of crackers that cost $2.50. So we're going to try to fill in this side. This is the amount of that she bought. So we're going to start with the bags of fruit. I see that it costs $4.75 for each bag of fruit, but we don't know the number of bags of fruit, so we're going to use the variable b, $4.75 per bag. So now it also looks like Harper's going to buy a box of crackers, so we're going to add what else she's buying, and it's one box of crackers, so we're going to add $3.50. And whatever she spends, she cannot exceed or go over $15. So this is the inequality that we need to start with. Now it asks us to solve the inequality. So we're going to solve. You're going to notice there's a positive coefficient, so we don't have to be concerned about switching the inequality sign. So the very first thing we do when we solve is we start with the constant. We're adding 350, so we're going to do the opposite. We're going to subtract 350 from both sides. And if you're doing this without a calculator, then you would want to add your decimal zeros at the end of 15. After we complete that step, we have $4.75 B. Still have our inequality sign going the same direction, and now we have $11.50. So now we are going to divide by our coefficient of $4.75 on each side. So would you please pause and take your calculator out? So you probably came up with a very lovely answer, and it looked like this, 2.42105, and then it continued on. So let's look back and see what we're asked to find. Well, they are asking us, B is talking about the maximum number of bags of fruit. So if I went to the store, I don't think I'd be able to buy 2.42105 continuing bags of fruit. So this would be a situation where we'd want to round. We have to assume that they're going to give us full bags of fruit and not have us buy partial bags of fruit. So we're going to say that the maximum amount of bags of fruit number of bags of fruit Harper can buy is 2. So now let's move on to the next exam problem on the second page. I'd like you to try problem number 29 on your own. It's very similar to our first problem. It just gives us the information more in a list form rather than a paragraph. Let's move on now to problem 11. Winston needs at least 80 signatures from students in his school before he can run for class president. He has 23 signatures already. He and 2 friends plan to get the remaining signatures during lunch. If each person gets the same number of signatures, which inequality can Winston use to determine the minimum number of signatures each person should get so he can run for president? So let's look at this, and they've already given us, this one we don't have to solve, we just have to be able to write the equation. So let's look at first the information that they've given us. They mention that he needs at least 80 signatures. So that means he could get 80 signatures, but he needs at least, so he should have 80 or more. So that implies whatever information we're given here on this side, whatever the number of signatures are that he gets, they need to be greater than or equal to 80. So that can help us eliminate right now 2 of the suggestions. Let's move on. It says he has 23 signatures already. Okay, so he already has 23 signatures. So he's on the plus side of, he's already added signatures. It goes on to say that he and 2 friends, oh, now I see where 3 comes in. He and 2 friends plan to get remaining signatures for lunch. If each person gets the same number of signatures, okay, which inequality can Winston use to determine the minimum number of signatures each person could get? So what they didn't tell us here is they didn't really define the variable clearly. The other examples define the variable for us. So let's define the variable. Let x, because they've obviously used x, would represent or equal the number of signatures each person gets. And we're talking about Winston and his 2 friends. So this would be the number of signatures. And since there's 3 of them, it makes sense why we have 3 of the friends each getting a number of signatures we don't know. So this would be our inequality. And if you look at that, that is choice C. So would you please try the following one, which is somewhat similar, but the good news is they define the variable for you. Take care, and I will post the key later.